Hello and good morning. Today is May 15th, Chapter 10, Lesson 8, Circles. Make sure you're open to page 338. There's a lot of information I'm going to go over to start off today's video. To begin with, I'm going to draw what we see there. So we have a circle, and the center of it says C. The center of the circle is very important. It's called the center, believe it or not. The center of the circle is very important for two reasons mainly. First of all, well, I guess a lot. I don't know. Maybe I won't try to limit it to two. But first of all, that's where we get its name. So the name of the point in the center of the circle is going to be the name of the circle. So this is going to be called circle C. Okay? So if you're told to go look for circle F, look for a circle with F at the center. Also, what makes something a circle as opposed to, I don't know, a lopsided egg or elliptical thing or whatever like this or whatever, that's not a circle. The reason for that is that in a perfect circle, which this is not, probably not because it's really hard to draw a perfect circle, the distance from the center to the, the side or the circle, the distance from the center to the circumference around the circle is the same no matter where you're at. So you could put a point here, 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 point here. Point in every single spot in that entire circumference. If you were to take out a ruler and if you were to have actually drawn this circle correctly, it would be the exact same distance from the center, every single part of it. So that distance from the center to the edge of the circle, so like from here to here, or from here to here, or from here to here, that's going to be the same. That distance from the center to the edge of the circle is called the radius. Okay? We're going to be talking a lot about radius. Okay? The definition of it on page 338 is a line segment. So here's a line segment with one endpoint at the center and one endpoint at the on the circle itself, which is this circle. Okay. All right. So a chord. I'm going to draw circle C a little bit bigger. A chord I'll just draw another radius, okay? So I'm going to put a point here, just like the book does. It labels that point N. So here's a radius. From C to the circle, it's N. A chord is any line segment with its endpoints on the circle. So, for example, here's N. Put another point here. That's M. This would be a chord. A line segment with one endpoint on each end of the circle. So that's a chord. Spelled like that. A diameter is a chord, so it has an endpoint on one end of the circle and another on another end, but it passes through the center. So if you wanted to make a chord, you put an endpoint there, K, and if you went straight through the circle, so from K to the center, and then you kept going straight, and then we can label that L. This is a chord that passes through the center. It's called a diameter. The diameter is always twice the length of the radius because, look, it's made of two radiuses, from C to K and from C to L. A central angle. Oh, I'll just write that. That's diameter. Okay, good. And then a central angle in a circle is an angle with its vertex at the center of the circle. So angle LCN and angle KCN are central angles of the circle we just made. So angle LCN would be LCN. That's an angle right there. See that? That's an angle. It's a central angle because the vertex is the center of the circle. Angle KCN, so KCN. That's another angle with its center vertex as the center of the circle. All right, this is not a central circle because it's not a central angle because the vertex is not the center. Finally, our final vocab term is an arc. An arc is a part of the circle with all its points on the circle. So arcs that the book gives us are arc, KN. So look at K to N, that's an arc. See, it makes an arc shape. Arc NM is here, so that's an arc. Just the part of the circle that's between N and M. And then the last one we can look at here is, well, ML would go from here to here. That's an arc. And then we have LK would go from here all the way over here. All right, so those are arcs. Okay, rewatch this if you need to remember what some of these things are when you're doing your homework. 7, it says with a circle that looks just like this. Okay, so O is the center. We have a radius going up here to point V. We also have a diameter from a point W to Y. And then we have a diameter from point X to Z. And then we have a chord from Y to X, which is not a diameter because it doesn't pass through the circle. Okay, name the circle. It's circle O because O is the center. And then the center is just point O, we would say. 8, name the 5 points of the circle. So the points of the circle are these guys around the side. Don't name O because it's not a point. It's not actually on the circle. It's in the middle of the circle. So these are the points of the circle, which are going to be X, W, V, Z, Y. How many chords of the circle are shown? Name them. 1, and that would be line segment XY. 2, and that would be line segment XZ. 3, what? No. 3 would be YW, and then 4 would be V. Oh, VO is not a chord because it doesn't connect to two parts of the circle. That's a radius. Okay, so we had 1, 2, 3. That's all there is. And the answer would be 3 for the amount. And those are the names of them. You're naming them as line segments. 10 is XY, a diameter of the circle. So here's XY. Is that a diameter? No, it does not pass through the center. No. 11, how many diameters of the circle are shown? Name them. So how many chords go through the center? 1, 2. That's it. And their names are line segment XZ and line segment WY. 12, how many radii of the circle are shown? So how many start at the center and go to the circle? Just 1. Does it say name them? Oh, excuse me, not 1. Silly Mr. Sudi, because even though this is a diameter, it's also 2 different radii. So there's OW and there's OY. So there's actually a lot of radii. Let's count them, okay? So let's start here and we'll work around like a clock. So OX is 1, comma, OW is another, OW, OV, OZ, and then OY. 1, 2, 3, 4, 5. Okay, so there's 5 total, and those are their names. You notice they say how many are shown. They're asking that because you could color this entire circle in drawing radii. I mean, you could go on for pretty much infinity. You could get smaller and smaller points around the circle. So you can't say that's the amount of radiuses there are, but that's the amount that are shown. You could draw another one, and then there'd be another one being shown. So there's like an infinite amount of radii, but there's only 5 being shown here. Circle that, circle that, circle that, and circle that. 12 says, I don't want to run out of room. I want to keep using this circle. I'm afraid I can't draw it again. that well. So I'll try to do it here. 13 is how many central angles are shown. So how many angles are there that have O as its vertex? There's one here. There's another one here. There's another one here, here, and here. And that's it. So we would have... well, there are actually going to be even more than that. This is where it's going to get interesting. So there's 1, 2, 3, 4, 5 that are easy to see, right? Oh, you're going to be mad at me, but there's actually more than that. So I'm going to write them all down, and then we'll look at how they all exist. So there's angle VOZ. It's going to be angle, write them down with me, okay? ZOY, angle XOY, angle WOX, angle WOV, angle XOV, angle WOZ, and then angle VOY. How does that exist? Okay, VOZ, it's right there. We get that one. Okay, ZOY, right there. Okay, XOY, so that would be XOY, right there. Okay, we have WOX, okay, that one's simple enough too. And then WOV, that one's simple enough, just like that. Here's where it gets interesting. XOV, watch this. XOV, that's an angle, like that. Okay, and then we have WOZ. So WOZ goes from here to here. So that's an angle. Okay, then we have VOY. So VOY would go like this right here. Okay, so all of those are angles. Apparently they're stopping where they're not showing straight angles. So they didn't count WOY as an angle. So it looks like the book is asking you to find all of the angles that are less than 180 degrees that you can make out of a circle. 14 is find the arcs. Let's just talk about them. You don't need to write them. So the arcs would be, you know, arc XY, arc X, WV, arc VZ, arc ZY, and then arc YX. Those would be the arc. And then what kind of triangle is XOY? Well, okay, XOY. Wait, XOY. Oh, that's a triangle. What kind of triangle is that? Okay. These are both radiuses, right? Is each radius of the triangle the same length? Yes. So these are equal. This is not equal to that because that's not a radius. So that's two equal sides. So the answer to number 15 would be isosceles. All the problems of your workbook that ask you to make a circle using a compass, you are excused from. But if you want to just try your best to make a nice circle like I tried my best, then you can just do that. Okay? But that's all. God bless you. Talk to you soon. Bye.